areas for the lymphatic system are going to be areas, for example, the thymus gland, okay, the lymph nodes, all right, those are going to be the lymphoid tissues. Now, when they do that, all right, for some of these cells that are going to be lymphocytes, they're going to have to move to that lymphoid tissue and proliferate in that tissue. So, for example, a white blood cell that needs to migrate to the thymus gland, all right? The thymus gland in children is huge, okay? And do you guys remember it as part of the endocrine system? All right? So part of this endocrine system with the thymus gland, it secreted a hormone, thymosin. Do you guys remember that with the endocrine system? It created thymosin. That is going to expose the immature white blood cell to that hormone, and it will develop into what we know as a T cell because it's coming from the thymus gland. Now, I'm sure you've all heard of T cells, right? Why?
Is that for the immune system?
And you've probably heard of it in relationship to something pretty specific. HIV. Yep. Oh.
It will expose it to thymosin.
The T cells, okay? We've usually heard of that because those are the cells that get destroyed by the HIV virus, all right? You won't believe how important they are in the immune system. What happens to people with the HIV that develops into AIDS? The weakened immune system, and you die because of everything else that your body can't fight off. You get exposed to everything, and you catch it, you get it, everything. That's why you die. Because your body has no ability left to fight off the infections. So the T cells are part of this, which is really interesting. Now, when we begin to look at the lymphocytes, they're going to be maybe 20 to 25%, okay, of the makeup of the white blood cells, with the majority of them being in areas such as the lymph nodes, the tonsils. Everybody knows about the tonsils, right? Okay. We're going to see them in the area of like the thymus gland and that sort of thing. So these particular cells, one of the other parts that's going to become important with these cells, we're going to see it give rise to something known as the B cells. So when we begin to talk about the immune system, two cells that are going to be able to leave and go and proliferate and work in the immune system, we're going to have our T cells and our B cells. Now, T cells are going to be from that thymus gland. B cells are going to be termed or come from plasma cells. Why do you think B cells are going to be, or why would I say plasma cells? What's one of the components of blood? Plasma. Plasma cell. Okay, so that's one
The
that
B
we're going
cells
to
come from plasma, or they are the plasma cell?
Don't get too ahead of me because we're going to talk about their proliferation when we get into chapter 21. I just want you to remember that for these white blood cells, B cells are going to be termed plasma the cells. All right? So just kind of put that in the back of your mind. They're going to have the ability for this. The B cells are going to have the ability to secrete the antibodies. Antibodies, basically what they're going to get to do, they're going to get to attach to a bacteria and they're going to get to destroy it. All right? Now, that means, however, that we are in our third line of defense. So that means that there's already been an attack mounted. The battle just wasn't won. Okay? Those original first cells, they're fighting the war, they can't win it. And they're going to have to activate these T cells and these B cells so that they can come in and help fight off these infections. The T cells that we'll get into, the T cells are really cool because they'll help with stuff like the viruses, little other bacteria that come in. They'll help with tumor cells, that sort of thing. So they're going to be very interesting, but they're going to be under this lymphocyte family. All right? So they're going to be under the lymphocytes. The monocytes, they'll increase in number with viral infections and inflammation. They'll stay in the circulation for about 3 days. They can move into the tissues, and when they move into the tissues, these can become macrophages, meaning they'll eat stuff. So when they leave the bloodstream and turn into the macrophage, they'll try to eat anything that's foreign, that they recognize as foreign, and then they can try, they'll eat debris, stuff that's like maybe dead cell parts or something like that, or dead tissues, all right? They'll come in and they'll eat that. Now, once again, they are going to have the ability to be an APC, an antigen presenting cell. They will be able to take an antigen to activate other immune cells. They only make up a small amount, about 3 to 8% of our white blood cells. They'll increase in number when needed, such as the viruses or the infections. If there's a chronic infection in the person, this particular white blood cell count will remain high, okay, due to it being chronic. Now, they will start a reaction, or they will try to get a reaction in 2 ways for the monocytes. First, they can release chemicals. So they can try to get other immune cells incorporated into fighting off the pathogen by simply releasing some chemicals. The second way, if the chemicals, are not cutting it, the second way that they can initiate a response, they'll function as that APC. They'll take a little piece of that pathogen, and they will, what will happen is, for these cells, they'll take a little piece of that pathogen and they'll engulf it, okay? They'll eat it, all right? And then they'll let it come up to the membrane, all right? And what they'll do is they'll take that and present it to those T and B cells, the lymphocytes, okay? Those T and those B cells to try to get them to respond. So those T and B cells that we're gonna find under these white blood cells, those T and those B cells, it takes a lot to make them activate. We have to really be losing the war against that pathogen. Did I yell? Hi, hello, Dr. Barton, how are you? Okay. Thank you very much. Oh, no, sir, I'll just do everything when I get back. Okay. Yes, and it did change, so when I get back, I'll just redo another one. Okay, all right, thanks, Ray. Okay, bye-bye. So, this is a view of those white blood cells, the A granulocytes, under the scope. So when we look at them, like I said, originally, when we had early microscopes, it didn't look like they had the little granules, okay? So that's why they were termed A granulocytes, all right? But we do know now that all of them have the granules. And if you think about all of these white blood cells, every single one of them has a very definite structure to them. 2 lobes, 5 to 7 lobes, 1 lobe. So they're all, you know, now I'm not saying easily identified, okay? Because I know trying to identify them under scope could be a tad bit difficult, okay? Now, the life history of the white blood cells. Do you guys remember how with the red blood cells, we had that one great big huge stem cell, and it gave rise to those colony forming units, and then the colony forming units gave rise to the stuff that became the red blood cells and the platelets, that sort of thing. So once again, we're going to find that we have a great big huge stem cell, okay? And this time, we're going to get colony forming units, but this time, those colony forming units are going to give rise to the white blood cells. And once again, we're in the bone marrow, all right? So this life history, this history of those, okay, it's the same stem cell as the red blood cells, all right? It's going to be that same stem cell. This time, do you guys remember what the production of the red blood cells was called?
Erythropoiesis.
The erythropoiesis. Well, this time leukopoiesis, formation of the white blood cells. That hemopoietic, that blood cell, that blood stem cell, all right, it differentiated into myeloblast, monoblast, lymphoblast. Well, look at this for a second, okay? A monoblast. Would you guys remember when I talked about the terms for cells? Blast was to do what?
Give rise.
Give rise to. And then cyte was the mature cell, right? So the monoblast, duh, just a monocyte.